Hi there. All right, guys. I am going to show you how to do an F-test or a single factor ANOVA in Excel. Okay, so I'm going to shrink myself down here. I'm still here, just a little, just very, oopsies, just very tiny. Okay, so we'll pull up our data sheet here. Okay, and what you're going to do, the first thing you need to do is make sure that you have this data analysis pack on your Excel sheet. And if you do not, I want you to hit the caps lock button, then hit the button that says ALT and hold down the capital T and the I. And that when you do that, that should have this little analysis tool pack pop up. And if you don't have those boxes checked, then I want you to check them and hit OK. And this little data analysis tool pack should show up for you. The next thing that I want you to do to run this test is you're going to click Data Analysis. You're going to click ANOVA Single Factor. OK. And then you have an input range, columns, labels, all this stuff. So the input range, you're going to delete what's there. And you're going to highlight with the headings. Okay. Oops, that's not the one I wanted to do. This is the one I wanted to do for you. Okay. Here, this one. We're grouped by columns because each of our genetic strains it heads a column. We have labels in the first row, so make sure that's checked. Our alpha is 0.05, and this represents the fact that about 95% of the time when we do statistical tests, we're wrong, but about 5% of the time we're right. And so we give ourselves what's called an alpha of 0.05. So anything that returns a probability value or a p-value of 0.05, 5% or less, we deem as statistically significant, meaning that there is a change that we're looking for. Okay, so we're going to put new worksheet, and then you're going to hit OK. And it's going to open up a sheet for you. So I just did the pre-attacks, so double click that and write pre. Whoops, I'm still in caps, and that's just A-OK. Okay, and write pre. Next, what you're going to do is take a look at, okay, the F value, the P value, and the F critical value. So your P value here, we're looking for less than 5%, and we are at 0.45. So that is not less than 5%. So what that tells us, in addition, what that tells us is that we don't have a statistically significant difference between groups as it relates to pre-exposure aggression. We also know that because of this F and this F critical value. So if our F here is 0.79 and our F critical value is 3.2, what that means is that if our F value is lower than this critical value, then there is not a difference between the groups that we're looking for. Okay, so if this F value was larger than our critical value, then there would be a difference between the groups that we're looking between. But for this specific test, there is not. So what you will do is you will go back and you will look at egg laying and post-exposure attacks, and also you're going to run this pre-exposure one and write about it as well on your data set that you have. If you have any questions, I will be holding some drop-in WebEx hours this week, and I will let you know when those are, and I will send you a meeting invite to your inbox. All right, have a wonderful day.